All right. So, who am I? So I've been a professional software developer for 16 years, and I've been working online with GIS data since 2006. I helped found the OpenLayers project, which was an early competitor to the Google Maps JavaScript in the open source world, and I was also a co-author of the initial GeoJSON spec. So if you've ever done geo stuff on the web before, there's a chance you've used some things that I have helped out in. Initially, I got involved in housing stuff about a year and a half ago, basically because I wanted to prove somebody wrong on a neighborhood mailing list. Basically, proving someone wrong is something that really motivates me in my life. So I wanted to look at the property data to better understand various details of how Cambridge was built, what houses existed, etc. And in the process, I created a data set to support the Every Lot bot for Cambridge. I think it was the first Everlot bot that like tried to do a little bit more than just post the pictures and actually like went into like how are these houses non-conforming in zoning and things like that. So this presentation, my goal here is to kind of go through in three parts. One is to talk through kind of simple web tools that I use all the time to answer questions or discuss things or look things up. The second is to look at like using basic GIS tools with data you just download from the city and can look at. And then the third thing is to kind of like look at combining different data sets. So loading data into a simple database, adding it to a GeoJSON file, exporting it, and bring it back into a geo information system so you can make cool maps. So those are the three parts we'll kind of talk through. And again, if I'm on a slide and you're like, slow down, you know, I really want to dig into this, please feel free, use the raise hand, shout, whatever you need to do. Okay, so thankfully, in Massachusetts, we actually have a lot of information about the properties in the towns we live in that's relatively easy to access. Most towns have an online portal for their assessors database. It contains information about each property, like the owner and the assessment and the year it was built and like the last time it was sold. You can usually search for property assessors database or similar, and sometimes you have to search by an exact address, but you can usually find this. And sometimes actually publish a download of all the data, like updated annually. So this is how like most of the Lotbot accounts work, is that like download a big CSV file, they load it into their database, and then they've got something that they can do. So Cambridge's property database is actually like one of my, oh, that didn't do what I wanted to do. How do I... Okay. Yeah, so Cambridge's property database is actually one of my favorites of the ones around here. It's actually got a fair number of like useful search tools built right in. So rather than like, you know, so if I live at 17 Laurel Street, I can search for 17 Laurel. My house pops up. You can see, you know, everything about it, and it includes like zoning information. Includes like map and lot information, like how big the lot is, and at the very bottom you'll find things like how much floor area and gross area is there. This is relevant if you're a zoning nerd like me to be like, okay, this has 1,245 square feet of living area, it has 2,544 square of land area, I know the FAR in this lot is about 0.5, etc., etc. So that's nice, but a nice thing about Cambridge is that you don't actually have to be exact. So you can search for just Laurel, and this is going to pull up all the houses on Laurel Street. This is really useful because sometimes when you're looking for a specific property, the mailing address and the street, like the assessor's database address and the street address are not exactly the same. So you can see like 16 to 18 Laurel Street is what the street number is in the assessor's database, which is not maybe how you would think about it if you were living there. I also always joke that Laurel Street is probably the most politically active street in Cambridge. This is all the houses on Laurel Street. And I have been at city council meetings where there were 5 different people from Laurel Street who were speaking at a city council meeting. So very active community that we have here on Laurel Street. But in addition to just basic address searches, you can also add other things, like you can look at, like, show me all of the, like, single-family homes. That's not how I do that. Sorry, wrong box. Single-family homes. Yeah, single is not spelled S-I, of course. It's spelled S-N-G-L, because that's how you spell single in a database. Just silliness. So this is, like, all the single-family homes that are between 2,500 and 5,000 square feet. So like if you're like, okay, I just want to see like the big single family homes in Cambridge, like just show me things that are more than 7,500 square feet, that are like houses in Cambridge that match that. And you can, oh, I didn't type things in right. Sorry. I typed 7,500 as a max instead of a min. So we can go and search like living square feet, 7,500, and find out like, oh, cool, we have some really big houses in Cambridge. Like these are things that exist here. So like that's a nice thing about the data in Cambridge that you don't always get in other cities. So you can look at filters, and this is a useful way to quickly look up information on a property. The property ID number will be something you can look up in other data and have links to, etc. But it's not just that property that's interesting. You can also look at like the rest of the stuff around it. So again, we'll go back to where I live, 17 Laurel, which I did wrong, but whatever. And we can say, okay, like I don't just care about this property. I want to actually look at a map of the city centered on this. And so this is Cambridge's like web GIS city viewer, but they actually have like a pretty detailed set of information that you can easily like click around and see, you know, everything around here. And I was mentioning earlier, like if this is like 198 River Street, but if you're looking for 56 Kelly Road, which is a mailing address, you might not know that. And so you can actually just click through all the properties here. And so sometimes when I'm looking for something, it will literally be as easy as like, okay, I've come to this map. I swap to a drawing tool. I'm going to create a quick sketch where I draw like some text on the map and I say like, hi. And then I'll draw like a circle around like this area, you know. So if you just want to do something quick that really has the information about this for a quick tweet or whatever else like this can be useful. You can also, if you've never used web maps like this before, sometimes you have to swap back and forth between like panning mode and selecting mode. But yeah, and then sometimes I'll be like, okay, like here's the two properties I care about, and draw a box around it. So this is like a useful tool, like without doing anything, without any software, without anything else like that. You can just come to the city, search for the address you care about, and then you can draw, you know, lines on the map and be like, this is the area that we should turn into a dog park. This whole street, just bulldoze the street, build a dog park. That's something you can do with no software. So that can be helpful for sometimes just yeah, so that lets you explore GIS data. You can kind of like look at, you know, click around to different properties. You can find nearby things. And sometimes it's just an easy way to kind of like browse around a neighborhood quickly rather than typing in a bunch of street addresses. This map also has a ton of details. So if you zoom all the way in on this, you'll actually see that, and it's really hard to see probably over zoom, but these little gray numbers here are actually like the distance along the lot line in each of these things. So if you're like, okay, how wide actually is like the lot that the house that I live in is on, you can actually see that it's like 32.12 feet wide, or this is 34 feet wide. And this is, again, for those of us who do kind of like zoning advocacy, can be interesting to think about from the perspective of like, okay, setbacks, right? Like setbacks in the area where I live are required to be at least 10 feet. But you can see pretty clearly here that like this distance is not 10 feet on any of these houses. And so we can like draw a measured length and say like, okay, cool. The distance here is only like 6 feet. Or if we, you know, do a measure to the front of my house, it's like it's 2 feet, you know, to the front of the house. So those are interesting things when you're thinking about understanding zoning, understanding the lots we have, understanding the city as it's built. This can be an interesting and relevant piece of information to have. Okay. So the other thing that I sometimes do that makes people kind of like surprised is like looking up information in deeds, right? So in Massachusetts, thankfully, deeds are all available online and searchable without too much difficulty. They're actually pretty easy to browse through. In some states, you actually have to pay like per page to see deeds, and that's really bad. So thankfully we have this, and deed searches can actually give you more information about like the historical transfers of the property, can help find you like determine historical information. And there's also just some interesting history built into this, right? So when we talk about, for example, racial covenants that exist in deeds, you know, I was browsing through some deeds that were in a nearby town, and just like going back in the history, and back in like 1904, when this deed was transferred, it said, okay, you can build a house on this lot. like, I'm going to split my lot with you. You can build a house on this lot, but it must be at least a $5,000 house, and you can't sell to, you know, any colored people. That's what the deed says. And some of those things are interesting to kind of go back and see the history of that. But from a perspective of kind of just like looking at a data perspective, it can be interesting to look at this sometimes and just understand more of what's going on. So if I look at 234, 236 Alston Street, which is another place that I've lived in Cambridge, sorry, I went that a little bit fast. So masslandrecords.com is the overall Register of Deeds, you know, parent website, and then each of the counties is split up into like a different place that you can search. So I clicked on South Middlesex because that's where Cambridge is, and then there's a bunch of different search types. I can search by name of who owns the property, book we'll get to a second, document, and property is searched by address basically. And then this is another case where you kind of have to type in the exact address, which you might not know, and you might have to look up from the assessor's website. Okay, so like this is a case where if I look at the most recent sale of this, I will see it was sold for $1, right? But I know that this property wasn't actually sold for $1. And so if I look at the Cambridge Assessor's database for this property, it'll say like last sale $1. And I'm like, well, I want to know like how much you paid for it when you bought it. Like, cause that's relevant to understanding, you know, if you're going to buy it for affordable housing, what are you going to sell it for, et cetera. And so by coming here to the Register of Deeds, I can come back and see like, okay, you actually bought this in, you know, 2000 for $420,000. And so that can be an interesting thing. And when I talk about going back further in time, you can also, if you click view images here, it actually shows you the full details of the deed transfer. So this will be like, I am selling this to this person for this amount of money, blah, 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 blah. And the interesting thing about kind of going back in history is that at the end of each of these documents, it will have more information about the last time this was transferred. So the, like in this case, so the page and number are details about like this entire database is indexed by book and page number. And so if we do this, right, and we take a quick note and we okay, 18717, page 004. Now we can come back and we can use this book search. And so even if the address is typoed or like something else like that, you can often come here and search by page. And when you do that, this probably just needs to be 4. Nope. I can't type. It's 18717, not 18707. There we go. And so I can come back here and see like, okay, this was lot B, you know, it wasn't described as 234, 236 Alston Street. And then I can go back even further in time. And so I can go, you know, trace this all the way back. So all of the information on deeds is indexed to back to 1974. So you can search by name or by address back to 1974. But beyond that, you can't search by name and address. Like it won't pull up anything older than like the 1970s. And you can see like that's the end of this list. And beyond that, the page numbers are actually indexed back to 1900. So that's pretty cool. Like you can see things that are further back. But what I was looking for recently was I was looking like, okay, I know that the owner of the place that I live now was a freedman who had moved up from the South and was a rope maker in Cambridge. But I want to figure out when he like bought the house, when he moved here, etc., and go back even farther. And again, this lets you, you know, you've got the property that you can go even farther back in past. I think someone's not muted. I'm gonna mute folks. Okay. Yeah. So, and then like on this page, you'll have the sale date, the book and page number for the last sale. So this allows you to kind of look up like, okay, I start here and then I go back to the past. And then if you get even further back in the past, before the 1900s, you can actually just look these things up in the books that they were in. And so like this is all indexed by the Mormons, who of course are big genealogy researchers. And so you can come back to like 1877 and you can browse around in these old deed books and read like the deeds back then. So you can trace this all the way back through history to see these kind of like ancient deeds, know by all men these presents that blah, 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 blah. And this deed language has remained the same all the way through to today. And you know, at some point they switched these books to like having some pre-typed stuff. You can see here that these deeds had details that were all in there, and they would like cross out bits they didn't want it and fill in bits. And that's where the book and page number comes from, is that these were physical books that the registrar of deeds, you would come to them and you would give them some information and they would stamp your name in the book and you would pay them taxes and so on and so forth. So yeah. Okay. So that's deeds. That's property assessors database and deeds. The other thing to be aware of is that a lot of towns, especially good towns, especially towns that care about open access, publish their data in an open data portal. And so, like for example, Cambridge publishes all the assessment data, all the BZA cases going back to 2014, every building permit, etc., into the data portal. And so if I come here, I can, you know, search here, and so you get COVID-19 cases. You can look at budget and salaries. You can look at data on the dogs in the like location of dogs in Cambridge, because all the dogs have to register, and we record what neighborhood they're in. And again, this is a case where you can make like, yeah. So we know the most common dog name in Cambridge is Lucy and Bella in 2017. And then of course that like the most common dogs in each neighborhood. So this is like cool things that you can do in Cambridge. Not always super useful, but you know, crash data, parking tickets, all these sorts of things are useful if you're going to tell a specific story. And so keeping in mind that like you do have a fair amount of data that cities tend to provide to you, again, at least good cities, to use. And this is where you would come to get the property database. So if you wanted to build a website that is like the city's assessor database, you could download this, you know, CSV file, like export it from here as a CSV, and then you would have this property database that you could have like address and property ID and like what type of unit it is, etc., etc., etc. So those are some of the like easy tools anyone can use. Well, easy, straightforward tools anyone can use. No need for any software downloads, no programming experience, no anything else like that. You can look up information about properties. You can get a list of properties that match some set of criteria you have. You can really think through all of the details there that you might care about as you're doing it. I'm going to pause there, because the next section is going to get into some more software-based stuff. So before I do that, I wanted to pause and give folks a chance to, you know, any questions or comments on that. I'd be happy to hear them.
Other than just make sure that in any follow-up email you send with slides that you include all these links, please.
Yep. Yeah, all of the links that I've gone to are basically in the slides already. So like web interface would take you to here, et cetera, et cetera. But yeah, absolutely. Bill. You're muted. Bill, you're muted if you're trying to talk to us.
Okay, sorry. Yeah, specific question, and maybe you'll get there later, so if so, ignore it. I was wondering if in the open data portal, we could sort by two things. Can we sort by the number of, like, when a unit was added, and if it had to go through a zoning process or a historical review to get that extra unit?
Yeah, so the answer is mostly yes and no. Are the two answers there. So the assessor's data doesn't actually tell you like when a unit was added, right? So if the building you're in was split to a two-family in 2001 or something like that, as far as the assessor's data, the assessors care about, it is now a two-family, and that is what they care about. However, you do know when things were built. So there is in this data, in addition to having like the type of roof and whether it has air conditioning and everything else like that, there is also the year built field. And again, this is really all of the information here is basically the same as what's on this page. And so what you'll see on this page is that this building was theoretically built in 1854. I think that's wrong. I think it's 1843, but that's fine. Which is an approximation of when the building was built. And most of the time you can kind of assume that that is there, approximately there. Now, if someone splits a unit or other things like that, most of the time this is not going to get updated. Even if they split into condos, the year built is not really updated or kept up to date in any meaningful way. So it's really just an approximation that you can use. As far as like zoning, like did you need a variance for this or other things like that? That is not a thing that you really have, but you do have recent data has, like if you look at building permits, right? Building permits for new construction, this table has information for each building permit of like, did this need like a special permit or anything else like this? So you got special permit and BZA hearing ID numbers that are here. And this data will have that. So if you're seeing something that's newly built or an addition or anything else like that, the building permit data will say, yes, there's a BZA number, or no, there isn't in this export.
And that goes back how far?
So I think this data only goes back to like early 2018 or late 2017.
Yeah, that's what I thought.
Yeah, so there's not like, I assume the older data just was in a different system that they don't use anymore. So that data probably exists somewhere in Cambridge's bowels of stuff, but not in a easy thing you can access in the data portal.
Thanks.
Any other questions on kind of these introductory web tools? Okay. With that, I will move on to the next thing, GIS, Geographic Information Systems. This is just a general term that's basically people use for anything map related. So GIS systems, that wasn't great. Okay, GIS is a useful tool for managing geographic data. So you can use the data to do things like show me a map of every tree in Cambridge. And you can use the data provided by the city of Cambridge to make a map of just about anything. So that web map that I was showing you earlier, where you've got like all of the different, like everything in this map, all of the houses, all of the driveways, all of the parking lots, everything in this map is in a file that you can easily download from the city's website without a problem. Like you can just go and download all of the green space data, all of the parking lot data, all of the gravel pit data, all of the paths, sidewalks, every streetlight, every tree, every single thing in Cambridge is reachable. And so Cambridge maintains this decent, oh, there's not a link here. I will add a link to this. So Cambridge maintains this decent GitHub website, cambridgegis.github.io, which has like links to all of their data, right? So they have the parcels, assessing parcels going back, to 2013. So basically how has the shape of the map of all the properties in Cambridge changed? And then the base map. Base map is basically just a word for all of the things that you would use to draw like a map of the city, as well as like boundary data, community development data, like commercial districts and zoning districts. You've got polling locations, you've got trees, you've got hospitals, water, landmarks. So where's all the places of worship? Where's all the taxi cab stands? As well as, like I said, street lights and municipal parking lots and so on and so forth. Okay, so like now the nice thing is that GeoJSON actually has this nice property that GitHub actually just maps it for you. And so like you can click on any of these files and just be like, okay, so I want to see every building in Cambridge. Like, please just load this up in my browser. Oh, that links to the wrong thing. So you can say like, please just load this up in my browser and show me every building in Cambridge. and your browser is like, well, I'm kind of cranky about it, but I'll do that. Sure, we can play that game. And again, you can zoom in, you can see all of these building outlines. And another interesting thing is that you can actually click on these. And what you'll see here is that they actually have not just the building, but also some more information about it. And so these properties here, so like base elevation is the elevation at the bottom of the building. And like top GL is basically the roof line. So I can tell that this is a 75-foot tall building. The Peabody Museum of Archaeology and Ethnology, the roof line is 75 feet up, and or rather, sorry, is 65 feet up, and the top, like the top, no, 75 feet up, and then the top, like the highest point is 103.7 feet up. And you can look up the information in this file will give you some information about like what is top SL, what is top GL. So this XML data has like some metadata about what is in each of these files, so you can actually understand those properties. So let's imagine, so I'm going to load up so QGIS is a piece of software that just allows you to interact with data. So I want to combine a couple of these things. We're going to work with the building map, and we're also going to just work with the election data. So we're going to take polling locations and combine this with the building map. So we'll start up QGIS, and we're going to load a layer. So layer, add vector layer. Vector layer is like GeoJSON files as opposed to imagery layers that are not. And I've already downloaded these, so like this is just a file you would have downloaded if you were working with it, right? So I'm going to click add. Yep, sure, whatever. Don't bother reading things. Just do whatever I tell you.
Hey, Chris, I hate to interrupt you, but is this being recorded?
It is.
That might be useful.
Yes. It is being recorded. Yep. Yeah, so now I've got my buildings, right? And this is the same data that you just saw in the GitHub map. Same data here, right? We've got this elevation, top SL, et cetera, et cetera. All right, so that's one layer. I'm going to load another layer. Layer, add vector layer. We'll come and we'll just add my election polling locations. Add my shapefile, click add. Okay, so now we can see I got little pink dots here for all of my polling locations. Great. I've got to start. I know a little bit about where polling locations are relative to buildings, but I'm actually curious about like, okay, what's the farthest someone has to walk to get to a polling location? Like, is Cambridge actually covered? Because I kind of feel like this section over here doesn't have a lot of polling locations. All right, so let's just see. If I imagine I want to say, how many buildings are not within a quarter mile of a polling place? And it might not be the right one, but any polling place. So here's what we can do. We can take vector. So I've clicked on my polling locations. I'll go geoprocessing tools. I'll click buffer. Buffer means like make it bigger. So I've got some points and we're going to buffer them. And I'll just say 1,250 feet. So who is within 1,250 feet of a polling location? Click run. And now I can see kind of the coverage of polling locations in Cambridge. So Cambridgeport is kind of heavily covered. East Cambridge, all their polling places are kind of clustered together, so the port gets a little bit left out here. And you still got this corner of Cambridge, formerly Belmont, in fact, carved out in 1885, that is not covered here. Okay, so let's say we want to actually go out and we want to go bigger than that. We want to say we're going to go 3,000 feet. Who's within like 6.6 miles of their polling location or a polling location? All right. Well, we're seeing kind of the same thing here. Now, almost all of Cambridge is covered. North Point and a little bit of MIT is not, except for Cambridge Highlands, because Cambridge Highlands is always the outlier. And so this area that was built in 1940 to 1950s, as I said, formerly a chunk of Belmont. It was carved out over a dispute in Fresh Pond, re-annexed into Cambridge in the late 1800s, and that's what we've got. So So this is like an interesting thing you can do, right? So like you can combine multiple data sources and just get a sense of this. And some of the things that I've done are just as simple as that. Like, okay, I will make a map of all the trees, which again is something that Cambridge has, right? So we can add a vector layer. Again, things I've already downloaded from this website, nothing unusual here. I can add street trees, click add, and click add. And I can see where every street tree in Cambridge is. And you can see, you know, the coverage of street trees in Cambridge, et cetera, et cetera. Whole lot in this Cambridge Common area, and so on and so forth. I wonder if this layer, so like sometimes layers have information you're not expecting. I don't think this will. Oh yeah, look, it even tells you the species. So like, here's what we're gonna do. All right, so we're gonna turn off our buildings. And so right now, everything is just brown. But I don't just want my trees to be brown. I wanna know like what type of tree it is. So what you can do here is we can come here, and so what I did here is right click on the thing and click properties. Properties is going to define attributes of the layer. Symbology is the word for what it looks like, style, etc. I'm going to go to, it's right now it's single symbol. Right now it's all brown. I'm going to go to categorized. Categorized is like, I want to color things based on some attribute of what they are, and they're all going to be the same color based on that attribute. I'm going to pick a thing, species SHO. Don't know what that is, but sure. And then I'm going to click classify. So what this is going to do is it's going to go through species SHO, and it's going to figure out what each of them are. So I've got red buds, I've got service berries, I've got silver bells. They're all here. So now I can click apply. And what you'll see is now Cambridge is multicolored. Now I know not just the street trees, but I know the type of street tree of every one of these trees. Now, granted, because there's like 150 tree types in Cambridge, this is not really the most useful thing. Obviously, you can't read these colors and associate them very well. But it's still an interesting thing to see kind of the mix. And you can actually see a little bit of this trend here, right? It looks like East Cambridge largely has a lot of the same type of tree, which is this kind of like brownish tan color, which are maples. And so if we look at the, okay, that one just doesn't have anything. Oh, is this just none? Okay, so this is actually null, I think. So let's see if we can uncheck the nulls. Okay, so those aren't real trees. That's why there was too many of them. Great, problem solved. I'm learning on the fly here. Learning on the fly. Yeah, so that's a thing that you should be aware of when you are doing styles like this, is that you want to be aware of like what is your default color, because the default color like is going to be, you know, something that may not be really helpful here. So in this case, I think that those were proposed street tree sites, not actual street tree sites, which is why they were all the same color, and there was a bunch of them in East Cambridge. But we can come over, now I found a real color, so we can come over to Northern Fresh Pond, and we can see that these actually all do look like they're the same, right? These are probably ashes. So if we look at these, we see a whole lot of ash trees over here. And so, yeah, so that's what we see. And these also say like what street they're on, the locations. There's actually a fair, as well as the ownership. So then we can do this again. We could come back here, change this from species to ownership, classify. Yes. Apply. And now we can see like who owns the trees in Cambridge. Well, the street trees in Cambridge are largely owned by the city, unsurprisingly. Some of them are owned by Harvard, also unsurprisingly. And then you've also got chunks that are DCR, right? So all these blue trees are technically owned by DCR, and you've got a few that are owned by MBTA. So is this... I think this is an MBTA one. I'm not sure why this would be MBTA, but okay, cool. Or is that just none again? Oh, this is other. Okay, so that's other. MBTA is a different green. So let's just look, where are the MBTA owned trees in Cambridge? Turn off Harvard, and we find out that there's a few over here. So there's only like 6 trees owned by the MBTA, and they're on Main Street, so this is probably in the plaza at like Main, in Kenneth Square. Yeah, so these are the trees that are right by Kendall Square. This is Main Street, etc. Like we can turn on the buildings here. So this is the Kendall Square plaza, and along the building just south of Main Street, there's some trees there that are owned by the MBTA. So that's kind of cool. Again, MIT owns the trees by MIT, and then you got a few mix in here that like we don't know who owns those or whatever. All right, so interesting things you can do with GIS. Like I said, I've learned things just in this process. I have learned things that I did not know about the data that Cambridge has. So there's just really a wealth of data available just from like taking the GIS data and dumping it into a system, kind of exploring it, colorizing it, making a map like this that you wouldn't otherwise see. All right. So let's see where I am in my presentation. Yeah, so we got assessment data, which is parcels. We have driveways and all the buildings and all the streets and all the curves and all the everything. So QGIS is the tool we're using. It's an open source GIS tool. You can load vector and imagery layers. So it's a useful tool for making like simple maps with color graduated data. So we talked a little bit about processing data to get the polling places. The other thing you can do is it also supports not just like vectors, but it also supports rasters. Rasters is a word for images if you're being a geodata nerd. So raster or layer, add raster layer. So now I'm going to go to the place where I keep all of my raster layers. Once my hard drive finishes spinning. There we go. So I'm going to add here two. So this is a historical map of Cambridge. This is Cambridge in 1957. So we can kind of scroll out here and see, unsurprisingly, like Cambridgeport was a swamp, and Ward 3 that was over here, like this is like East Cambridge, the small part of East Cambridge, and then like south of East Cambridge was a swamp. So what does that look like now? Well, now it looks like, you know, the part that wasn't a swamp is all the small buildings, and the part that was a swamp is all the big buildings. And you'll see this kind of consistently throughout Cambridge. Like the place where there's bigger buildings are areas that either did not used to be part of Cambridge, or more realistically used to be a swamp. Alewife is built on a swamp. Pretty much the whole area here is built on a swamp. Cambridgeport, you know, all this area along eastern Cambridgeport, yep, previously swamp. MIT used to just be river, like it wasn't even swamp, it was river. So you can kind of see that. And you can also, Cambridge actually has a bunch of different kind of historical layers. So I'll also add this 1916 map, which you can kind of see the progression of the city here, right? So like in 1916, you actually had, and we can close, I'm gonna make this smaller. You actually had like MIT is on the map, but you can see that in 1916 the plan was, and perhaps some progress was made on this, is that like they were going to split this all up. Like they were going to make this all streets and plat it out and turn this into a bunch of like plots to sell off for housing or like commercial or whatever else like that. But we know that didn't happen. Like we know that is now where all of MIT's fields are. MIT basically owns everything that's kind of east of this line if you're not from Cambridge. And so you can kind of see that. You can also see, again, historical, right? So we can look at, you know, the Washington Elms and see like that got built over a bunch of what used to be buildings. This is an 1940s commercial or public housing project, and you can kind of see all through here like how the buildings that were there in 1916 are now gone, and now we have, you know, public housing there, Cambridge Housing Authority project. This is also like, you know, I love the history of this. I love looking at like the soap factory and the piano factory. One thing that I noticed last night that I thought was amusing is that the Boston Confectionery Company is now where this is the Tootsie Roll and Junior Mint factory. So this is like continues to be a candy company. Cambridge's history as a candy company, like all the way back to 1916. Obviously, though, it was not the case in 1965 that building was there. So it was built in between, and something was demolished to put it there. One other thing I'll mention is that like you can see here that like Fresh Pond even though Cambridge Highlands is here, right? So you got like this few properties that are owned up here, the tuberculosis hospital is up here, etc. Fresh Pond is actually not complete here because Cambridge didn't actually acquire the rest of this street until even later than this. And so now Cambridge goes even farther out, but in 1916 it didn't. So you can see in 1957, Cambridge only had up to half of Fresh Pond. By the 1916, Cambridge owned all of the land around Fresh Pond, but nothing was built out there. And then later on, we kind of carved off this last little chunk from Belmont and called it our own. And of course, like some of where we build things used to be ponds. Like when you look at where our kind of new big buildings today, they're almost always in places that used to be underwater or a swamp or something else like that. And so Mill Pond Playground, the former name of what is now called Hoyt Park, used to be a pond. That's why it was called Mill Pond. Now you wouldn't know that. This is a baseball field and a couple of other things, but yeah.
Where do you get these GeoTIFF files that you've been using?
Yeah, so this is another thing that so Cambridge these are not in the GitHub thing, but if you go to the Cambridge GIS website, so there is like a link here. I think this takes you here. Yeah, so if I click GIS data, no, yeah. So I come to the GIS data page on the Cambridge website. There's a data downloads file here, and then there's two categories that have images, I think. One is, no, I think they're all images. So this images brings you to orthophotos. This is like the modern imagery, 2018, 2010, 2003, 1995. You got historical aerial photos. So these are black and white dating back to the 1940s. And then you've got historical Cambridge maps from 1854, 1865, and 1916. There is also, like, the Harvard Map Library also has more than this. So at one point I actually took then they've geotagged all of them and everything else like that. So at one point I actually took and I had a 17 layer deep map of Cambridge kind of through the years. So I had like another 10 or 20 maps that were kind of tied in here. So you could kind of see the evolution of the city as it got filled in. So like one thing I learned from that is that like before MIT moved to Cambridge, this was in 1910-ish, I think, the plan was actually to have this whole thing be just like this kind of like neat like DC style angled roads, like northwest, like split into quadrants, etc. Is a very different plan. And then MIT came in and is like, actually, we just like to buy this from you. And now we have MIT. Bill.
So when you import those historical maps in, do they come in aligned with the Cambridge GIS set?
Yeah, so this is one of the things about like the Harvard Map Library. So the thing to look for, right, is you'll see scanned and georeferenced is the words that matter. And because the Harvard Map Collection happens to be in Cambridge, they have done a fair amount of the maps in Cambridge, which is why we've got the lovely property of all this. So if you go to the Harvard Map Collection, that's where you get all these. And some of this would be harder, right? Like, so for the Bromley maps, these kind of like insurance maps that I'm using here, which you'll see all over the place, by the way. Like if you use this map, you'll see it, like it is like people use this for art in all kinds of buildings. This is like 16 pages from an atlas. And so you can see here that they were like turned into a seamless mosaic by some company that Cambridge contracted out to. And they give you this nice big GeoTIFF that you can use. So that's why we have like, okay, for the older map, you get a seam in the middle, and Bromley, like Cambridge went and did it. So yeah. So again, cool things that you can do with the geodata that you can download from the city. And these are all going to be on the GIS portal on the Cambridge side. Another thing I'll mention briefly, Cambridge also has 3D maps of the entire city. And this is downloadable as well. So you can actually download like a SketchUp file that is like your entire neighborhood in 3D. And I have in the past actually like taken a building like this and been like, okay, like if this building was moved to, this location, what would it look like? And so if we go to, let's see, I think somewhere on here, handouts. Oh, I got rid of that page. Okay. Yeah. So at one point I actually put together basically like I mocked out a building and just put it in a neighborhood in Cambridge, right? Like I said, okay, here's the most size you can do in a building for the affordable housing overlay, downloaded the SketchUp file and put it in the context of like a West Cambridge house. Cause this was a concern that people had is like, what would this look like in West Cambridge or whatever? And what I learned in the process is like, I would show this map to people and they'd be like, okay, which one's the affordable housing building? And they couldn't tell because all these buildings are stupidly tall anyway. Like they're like, but yeah, so that's another interesting thing. You can see like all these trees are here. These are like, this is the buildup of all of that data. You can load it up in SketchUp, you can use it, or you can just kind of like browse around the city and see like an entirely 3D view of the city. That isn't like the Google Maps, like weird aerial stuff laid over it. Like this has all of the like the pointy roofs and everything else that you might want to see. So yeah, that's one of and yeah, so this is my house where I live, and you can see the distance between my living room or my kitchen window and the next door neighbor and the shed out back and so on and so forth. Just another cool thing that Cambridge has that I forgot to mention. Yeah, so raster data available on the city's GIS data downloads. They don't put it on GitHub because it's giant, but it's there as well. And this is all the same data again. These are just in shape files rather than GeoJSON files. Not a big difference for most people. I am not updating my mouse drivers, sorry. Cool. All right, so those are the things that are designed to be like, if you just know how to use computers, I think you can work this out. Download the data, you can make maps and do everything else like this. Now I'm going to get into the kind of more nerdy parts of some of the stuff that I have done, and like the software e-bits. So if you're like overwhelmed from this point forward, don't feel bad. It is totally fine. But I am going to share some of what I've done and point to some tools that could help you do some of the same. Before I do that, though, any other questions on kind of like the QGIS? And again, QGIS and the links for all of the software are in slides at the back. And I will send these out via email, so you don't have to worry about like scribbling down QGIS. But does anyone have any other questions on kind of like what you might do with this or how it works? Linda?
Yeah.
Maybe?
Is there any information about ownership, such as a map showing all the buildings that Harvard owns, something like that?
So there isn't really. We'll get into that a little bit in the next section. So the big question, so if we go back to here, right? Like one of the things in the assessor's database is who owns the property. Obviously I rent, so I don't own my property. But you know, so if we come here and we search, I'll just go to 1400 Massachusetts Avenue. I click search. I come over here. This isn't Harvard, but it's nearby. So the reason I do this, right? I basically know where things are in Mass Ave. I search for an approximate address, and then I'm like, okay, cool. Like now I can click here and get to the property I actually wanted because I didn't know this was 1341 Mass Ave. Anyway, so yeah, so 1341 Mass Ave is owned by President and Fellows of Harvard College. The assessor's data has this information in it. It has President and Fellows of Harvard College, but the parcel data you download doesn't have that owner information in it. And that's exactly what the next step is designed to answer. So it is a good leading question to my next section, and we'll try and do exactly what you said as part of our GIS demo. Okay, cool. So now we'll go into this is something like command line tools and using databases to kind of munge data. If you've used SQL before, this will not feel scary to you. If I say SQL and you're like, what is that? Then it's okay. I think you'll still see some of the results in a minute. So 4 steps. 1, we're going to load the property data, the assessor's data, into SQLite. SQLite's just a lightweight database. Then we're going to load the parcel data, so that GeoJSON file that you can see with all of the lines of where all the lots are, into the same database. We're going to combine the two so that we have all the information associated with the geographic information, and then we're going to make some maps. So this is the next step there. Okay, so SQLite is a lightweight database, right? So dealing with like 50,000 row spreadsheets in Google Sheets, it sort of works, but it's a little bit of a pain in the butt, right? So like if I come here and I'm like, I only want like 8-unit apartments, and I wanted to then filter this further to things that have more than 10,000 square feet or whatever, like that gets a little bit hard. And if I wanted to ask another question, which is like, what is the number that have each of like 8 bedrooms and 9 bedrooms or whatever, like again, it gets harder and harder. All these things are doable, but a database is just like spreadsheets plus. So we can like manipulate the data to compute new info, etc. Okay, so the first thing we're gonna do is, we're going to open up. This is just gonna be a I want to make a new database or new directory. Present. Okay, so I'm just using an Ubuntu window that's in Windows. This is like the Windows Linux subsystem. If you've ever used a Linux machine, you'll recognize this. If you've ever used a Mac, you may know the terminal. I'm just doing things in here. No, nothing that special. Okay, so I'm just going to download the assessor's data. I just went, this is the link that I showed you earlier before to download the data. I'm just downloading that CSV file. So I got my 13 megabyte CSV file, and I don't love working with 13 megabyte CSV files, so I'm going to put it in a database. I'm going to load up SQLite. I'm going to switch into CSV mode, and then I am going to import that data as the properties table. So now if I do show tables, or show describe table, why? Oh, .schema. Too many different database syntaxes. Sorry. So schema tells you all the information. So this is basically like if you look at the first row of my CSV file, like it's now been turned into the schema for this database. And I can ask it questions, right? So I can say like, show me the like the identifier and the number of bedrooms. So the PID is the property ID. Interior bedrooms is the number of bedrooms from properties where it's a single family resident and it was built after 2015. So run this query and I get 6 results. So since 2015, there have been like this handful of single family homes built in Cambridge. So the year built is like, the year it was constructed as far as the property database is aware of. And I can look at these. So I've got like a 1 bedroom, and so I can take this, and this is the nice thing about Cambridge's database. You just got a nice little link here, and you can put the number on the end and be like, okay, cool. This seems wrong. Did I type that wrong? PID, interior bedrooms. Okay. So this claims it has 6 bedrooms, so somewhere in there I think that got a little bit messed up. Not sure exactly what happened there, so we'll pull up one of these other ones. Okay, so this one, the database claims has 6 bedrooms. And if we scroll down here, we do see it has 6 bedrooms, and we can see it was built in 2016. It's in superlative interior condition because it's a new house. And so like, this is a property that was built in Cambridge, and then we can come back down and look at a 2-bedroom. So let's look at a 2-bedroom single family house. It was theoretically built in, since 2015. House looks modern to me, so I buy that. And so you can see like a relatively new construction. And in fact, this house is owned by people who live nearby, but not in it. And they bought the property in 2004. So they've owned this, since long before they built the house that's on it. They tore down what was there before, and they built something new in 2018. So that's a question you can answer. The other thing that you can do is, go the other way. Okay, I want to see all the properties in Cambridge that are, single family houses with 9 bedrooms. Just in case, I'm looking for some place to put my family and their extended relatives. and you get, you know, nine bedroom single family houses. So we see it has 9 bedrooms, and we can see that, yeah, it's a 6,000 square foot house that has, you know, 9 bedrooms. So this is less useful. Like, I'm just giving examples here. But like, what is interesting is that you can see in this case, this last column is the year built. So I can ditch these others just so that's easier to read. And these are all built in the 1880s and early 1900s. Now, of course, it is also the case that if we look at when things were built in general in Cambridge, condition here built, count, we'll just look at every property, group by 1, order by cast as integer, just so these sort well, order by 1. Okay, so we're going to just kind of scroll through and see like when things were built. Now you have to keep in mind this includes like every condo is a different record, etc. But we can see that like a lot of things were built in, well, 1900 is probably a data error, but there was a lot of things built per year for a long time. If you look at the 1950s, there's a lot less per year that was built every year. In the 1980s, we built more. And so when we look at, there's a map that maybe got linked in one of these things. And so one of the things I did is like looked at the buildings that were built by year. So we'll talk about buildings in a second. But you can see that we built a lot before 1920, 1930. And since then, we really haven't built many buildings. We built a lot bigger buildings. Like if you look on the map of what has changed, you know, it's all big apartment buildings now, but the number of buildings is nothing like what it was in the 1890s, the 1920s, the 1910s. These are all, you know, much more construction going on in Cambridge. Okay, cool. So now we've got information about properties, but properties are not lots. And so I talked about the fact that like, okay, that included condos as separate condo buildings, and like that, like knowing that a condo was built in whatever, like that's not really helpful to you. So here's where you can use the fact that this is a nice database and the fact that it has a GIS ID that ties to the parcel number. And we can just tie this all together. So we can say, instead of grouping everything to the property, we can group all the condos that are on one lot together and get answers here. So this is just like a SQL script that kind of takes the number of combines the living area, combines the land area, combines the number of units, combines the assessed value, etc., puts it all together, and parking spaces, and just gives me this nice little table I can use. So I can just fix this real quick. So I can run this query, and now show tables, no, this schema of lots. So lots is, this is when I do a lot of my like research and posting and everything else like this, and I like say like there are 12 lots that have houses built before 1920 that have 9 bedrooms or whatever. This is what I'm using to do it most of the time. It's a simplified table. It doesn't have all the columns in it, but it's grouped by the parcels. And so this is really important when we want to do these kind of joins to talk about like who is the owner, other things like that. Like this is where that becomes relevant. I don't know if oh, chat has words. I'm sorry. Cool. Like Zoom kept popping up at me and telling me I had chat, but it didn't pop up in the way I saw it. So I'm sorry if I missed anything important in chat. I see it now. Okay. So, yeah, and so this has most of the same information, but I've combined it with, you know, year, like just in a more useful way. And the important thing about this is like, if I'm going to make this map that has everything colored by parcel, I need to know what year the thing on the parcel was built. And if there was one condo in it that was like split off in 1982, that's unhelpful to me for the thing that I care about. So, now I've got the lots. Okay, so now I've got the lots, but I don't have the map data. So this is where we can come back and do the next thing. Is okay. So OGR and it doesn't stand for anything. So don't ask what it stands for. It literally doesn't. Like there's no acronym it stands for. It just is OGR. is a command line tool for managing geographic vector data. This is like a command line version of like the QGIS tool we had before, but it has tools to do kind of conversion between formats. The data that I have is in like the website, the GitHub website is in GeoJSON, and OGR can put that into my database. So if I, remove my database, and then I start here, we'll go back. Get this. Fix that while I'm here so I don't forget later. There we go. All right, so now I've got my parcels file, and I can take this, run OGR to OGR, which is just basically give me geodata to geodata format. And this doesn't work because slides are bad. Try this again. And what this is going to do is that, like, now, if I run OGR info, which is like, give me information about this file, I can run it on my parcels data and say like, okay, show me information about the parcels. And it's going to have like the polygon. And the key thing here is it has ML. So what does ML mean? Well, ML, to come back to this proper database, is for map lot. So this number, map lot, is the same as ML, is the same as, in the assessor's database, GIS ID. All those are the same. We can use all of them to look up the same things, which means that we can do a join on it. So if we go back, we can reload into our database. So we'll go back a couple slides. And I do have a script that just does all of these things, for you, so you don't have to worry about running these things one at a time. All right, and that's linked in the back of the slides as well. And now we're going to take this, copy it, run it. Now I've got lots. Okay, so I have now loaded up my data. So I have two things. I have the lot table, I have the properties table, and I have the parcels table. So parcels is the geo information, lots is the lot information, and I just want to put them together. So this is where I can use my power of SQL. I can create myself a table that just puts them together. Select star from lots, left join parcels on lots.gisid equals, etc. I will copy this and actually paste it because I am good at computers, I swear. Boom. Create table meta parcels, and then we will tell OGR to OGR how to read it. Boom. And so now if I do schema meta parcels, so the key thing here is that we've got this extra, we got geometry. Geometry is, again, the like shape. And we've got all of this other information. Now, I realized in hindsight that there's one thing that I was asked for that I do not have. So I'm going to change this quickly. All right, drop table, meta parcels, drop table lots. And someone asked about ownership, right? So where's the owner? The owner is owner name. So in this query that builds things up, I'm going to add min of owner name. Doesn't really matter which, because I assume they're not going to change, or if they are, I don't really care, as owner. So that'll just give me the alphabetically first owner for every parcel. Since I care mostly about Harvard in this demo, that should be fine. And we will come here again and recreate our table. So now my lots table has owners in it, something I didn't care about before, but we're going to for our map, because we're going to try and see what Harvard owns. We create our meta parcels table. We already did this other thing. Great. So now I've got a database, but I can't see anything in the database. Like I can say, select geometry from meta parcels limit 10. It gives me nothing useful, like completely useless to me. But what I can do is now I can go the other direction. I started from a GeoJSON file. Now I can into the database. Now I can go from the database back into the GeoJSON file. It'll give me some warnings because who knows? And I can drop this into a folder. Okay. So now all of that, by the way, is available in a script. And again, this is linked in the back of the slides that I'll send out. But basically, this is the script that I ran. Get the assessment data, get the parcel data, put the parcel data into a database, like put the data into like the lot data, and then combine them and spit out GeoJSON. So you don't have to worry about knowing what all those steps are. They do exist. They're in a place that you can just download and run if you've got the ability to run Linux scripts. All right, so I don't care about this map anymore. I'm going to throw it all away, discard, get rid of it, out of here. Maybe. So my computer doesn't crash. Great. So now we're going to add that data set that I put together. So I called it meta parcels. We can come to my downloads, metaparcels.geojson, add. And so we can see that we've got all the parcels in Cambridge. Okay, makes sense. Interesting that there's a small gap here, but okay. Anyway, so, and what I have now that I would not have had before is I can click on this feature and we can see it has the owner. So the owner here is United States of America. That's the post office, so that sounds about right. The owner on this property is the president and fellows of Harvard College. All right, so if we want to change this layer to be, we're just going to look for owners. And we're just going to add one specific value here, which I didn't copy paste out of here. President and fellows of Harvard College. Get rid of the space at the end, apply. All right, there we go. So what we've done here is we've actually mapped out all of the property that is owned by president and fellows of Harvard College in Cambridge. So yay, I did it. I didn't know how it would work, but it looks pretty good. Now I will say, like MIT, this would be much harder. So if we come over here, I'll just briefly show you why this is harder. So MIT owns a bunch of these, but if you click on this, you'll actually see that this one is owned by, hold on, let's scroll this over. Okay, so this one's owned by MIT, but this one is probably owned by, oh, interesting. I thought, okay, maybe this actually works. In general, MIT puts, like a bunch of these are owned by different LLCs. So I'm a little bit surprised that this actually worked as well, but it does actually look like it will. So we'll do the same thing here. We'll come here. Again, we're using this categorize symbol. We're going to add another value, which is Massachusetts Institute of Technology. Apply. And yeah, so we can actually see a whole bunch of the stuff that MIT owns as well. Now, this isn't going to be everything. Like I said, I think MIT has some weird ownership stuff on some of those other properties. I know that I think 24 Waverly is something they technically own. Yeah, so MIT 128 Sydney SPE is also MIT. So let's change this as well. And let's see. So we're going to get rid of these. Actually, here it is. Okay, so if owner contains MIT, else owner. So this is a way to do, oh, I guess I can't do contains. Okay, well, so like if owner, you can do like if owner equals MIT, like this is a thing that you could do. I wonder if I can do like, okay, like MIT. So this is going to apply this as a filter. And now what should happen is that most of this is going to go away. But if we add MIT, click OK. So these brown ones here are the properties that have MIT, that start with MIT, but are not owned by Massachusetts Institute of Technology. And these are probably like mostly Matimco owned properties. So purple is MIT, brown is starts with MIT, but not, you know, that. Yeah. Okay, let me go back to my slides and see what else I was going to say. Oh, right. So that was an interesting demo, maybe of doing a little bit of an evaluation. But the more interesting thing, of course, is to kind of like do math, right? So what I have at the moment is that I have living area, and I have lot area, but I haven't put them together. So we're gonna clear out our everything here. If I just get rid of this and apply, does that clear it out? Yes. Okay, so we've got, we want to look at FAR. FAR, floor area ratio, is a number that is used to describe kind of like how much building is there on a lot. So we're going to say, and we're not going to do categorized because like there's a lot of numbers. We're going to do graduated. Graduated is like along a scale. We're going to present this. And we're going to do, we'll start with living size divided by lot size. Click OK. Classify, and we're going to split this into equal groups. So these 5 colors that we've got here are going to kind of split up the city based on kind of like how dense the buildings in them are. And so like you can see here, like over here, I did this and I was like, wait a second, like my map got screwed up. All of these buildings are white. Like what is wrong with that? But it turns out that that's actually right. So if we wanted to debug that, we can come here and we can say, okay, we don't just want to color it. We actually want to have a label. We're going to add a label. The label text is going to be, oh yeah, here, we'll make this another. So this is living size divided by lot size. Click OK. We're going to format it as a number with 2 decimal places. Apply, click OK. And now we can see that, yeah, all these lots are about 0.25, 0.3, 0.1 FAR, while these ones right next to them are 0.83, 0.87, you know, etc. And a lot of this just basically comes down to the zoning, you know, keeping things the way they are. The zoning, of course, post-dated a lot of those buildings being built, so it was designed to describe the way they are, and then kind of they stay the way they are. We can see the FAR of, you know, Dana Park is 0. There's no buildings on it, so it doesn't have any living size, only anything else like that. And then you might come to this map and you're like, ugh, this is unreadable, like with all these numbers. So we can actually make it so numbers only turn on below a certain distance. See if I can find that. Rendering. Yeah. So rendering, we're going to turn on scale dependent visibility and say, this is only going to apply below, you know, 1 to 834. We click OK. We zoom out. Doesn't display. Zoom in. It does display. So just some interesting things you can do there. And yeah, so this is a case where, you know, just making a simple map like this, something you can do. This is a way that I have created many of the maps that I've kind of tossed out, is something similar to this, is like create a quick map that shows some dimension I care about and do that. You can also, you know, we could come to this and do, if we were talking about bedrooms, right? We could say like, this is just number of bedrooms. We're going to classify it. And this is going to be kind of silly because obviously like this building has a lot of bedrooms because it's like not a single family building. So we can come here and we can basically say like, okay, we really only care about this if it's a single family home. If type equals SNGL fam res, then bedrooms, else null. Click OK, apply, classify. Yes, apply, uncheck the all other values. Okay, so now we've got single family homes colored by the number of bedrooms they have. So we can look over here and see like, hey, these things have a lot of bedrooms. I can come over here and see like the single family homes in Cambridgeport have fewer bedrooms. A little bit unsurprising there. And just, you know, interesting things like that. And this is also like, you can see kind of the Wellington Harrington This is still being labeled on FAR, but this is like in the 1980s. We kind of took this from formal industrial land, turned it into housing, and all of those little areas, that single family townhouse dimension that's over there. Yeah. Okay. So that's it. I had 10 minutes left in my scheduled time. So now open questions, like things you want to know, whatever else like that. I know that I probably just talked some of your ears off. Half the people already left, but what do you want to know? James, go ahead.
That script that you have that combines different types of data from different sources, that looked like it required Linux to run?
Yeah, so I'm running it so Windows has like the Windows subsystem for Linux. So that's what I'm using. So I basically this is a button you can click to be like, hey, just give me a Linux shell. And so I'm actually on my Windows machine doing that. You can run it in Windows. Like you can install OGR and SQLite in Windows. There's packages to do that. It's much easier for me to just do it in Linux, which is why that's what I do. I'm going to move you all over here so I'm not quite looking so far over. So yeah, so Windows subsystem for Linux is what I'm using, and that's yeah.
All right, thanks.
Yep. Sorry, I can't see a name. Kirill?
Kirill?
Yeah.
Kirill, yeah. Sorry, maybe tell me if this is not appropriate for this workshop. Any tips or any gotchas we should be aware of dealing with other data from other towns that you've come across that would be worth noting?
Nothing that I've really come across. It's basically I find a very similar, like in Massachusetts, at least. I don't know about other states as much, but in Massachusetts, I've found them to really have very similar types of properties. So if I come to my GitHub repo for dealing with this stuff, if you look at the data loading script that I have for Brookline, it basically does exactly the same thing, right? We download the data, we get updates, we load in the parcel data, etc. So one nice thing about Cambridge is that we do have the zoning data that's built right into the assessor's download. That's true of some Massachusetts towns. Somerville, of course, just changed all their zoning, so their data is out of date. But I also have a script in here that actually and this is just kind of actually a general intersection script. So it's okay, take a polygon map, and then combine it with, and then go through every parcel, everything else in this other polygon map, and anything that overlaps, spit out a CSV file of that. So if you have parcels and zoning, or if you have neighborhoods and parcels or anything else like that, you can be okay, for every parcel, give me the zone it's in. Or if you wanted to say I just want to describe tax assessment districts or precincts in an electoral map or anything else like that, you could do that. So again, this link is in the back of that. And so the Brookline is the one I did more recently, and it has some of the kind of more, I had done it before, so I didn't screw it up quite so much. And so that's where I would look. The Brookline example is good. I'm going to be cleaning up Cambridge and adding more documentation here for some of the stuff that I've done as well. But yeah. Simon.
Wondering if you've played around at all with Earth Engine, and if you've thought about, I don't know, using it for any of your analyses, or you've kind of mostly stuck to GIS.
Yeah, I've stuck to GIS because it's what I know. I've been doing online maps for 15 years now, so this is what I do, and it was nice to kind of get back to my roots of things that I was doing back in 2006, and make some of this stuff. So I expect that for some people Earth Engine would be better for it. For me, I expect it would just be a learning curve that's not worth it. Suzanne.
Yeah, thank you, Chris. That was really great. And as a fellow GIS nerd, it's not always that easy to explain. So I think you did a great job. I have a question about whether you can bring in Cambridge infrastructure things such as the electric grid, traffic, water, plumbing, et cetera, into this, just thinking going forward about particular areas of further development and how the current grid plays out against that.
Yeah. So just to go back to the Cambridge GIS data has a lot of that. So for example, like let's see. So there's this whole infrastructure thing where they have park benches, street lights, utility poles, etc. And this data is not always super clear, so you'd have to really work through it. I was at like a pole and conduit commission at one point, and actually learned that I think using the streetlight data, so these are all like little markers, but using the streetlight data, I was able to understand like, okay, they're running conduits from this numbered streetlight to this numbered streetlight, because that's actually where they are. So 31158, they're running a conduit from 31158 to 31167. It means there's some conduit underground there. So those are things that definitely you can do some of that with. Whether a question can be answered with, the geo data that we have in the world, another question. Like, I can't answer how many feet of conduit or cable there are underground, or, I can't tell you that Central Square can't use solar panels because Eversource sucks from this data, because the city doesn't even have that data, but some of it is there, and especially around kind of infrastructure objects, like physical objects that you can map, are pretty common in the data that we've got. So basically, if you can look at it on the street, it seems to me that the city has tried to put it into data, and that seems to be what they do.
Thanks.
Yep. Bill.
So is there any mapping of Cambridge data to census tracts so you can do comparisons with census data?
Yeah, so this would be one of those cases where we would probably want to combine so that the script I was talking about before, that like you can take zoning and then figure out for each parcel, okay, what is the zone that is attached to this? So like I could take this file, which so I could take this file and I could dump out a CSV file that was like, okay, for every parcel ID in the city, which census tract is it in, and then have that in the exact same back into the GIS data and do the same kind of queries that we did like with the owner name. That would be how you'd add that extra column in there to do more analysis with it. Last call for questions. Perfect. I timed that great. Oh, good.
Chris, I have one question.
Go.
Is there a place that people have been like aggregating questions that they would like answers to using this data?
Not that I'm aware of. I think for me personally, it's mostly been like, I see someone kind of like mention something on Twitter and I'm like, I have an opinion on that. Let me see if I can back it up with data. So that's been my approach. I'm not aware of anything that's kind of like more general. So that's how I basically came to all of these. It's like, looking at the map of setbacks and seeing that like nothing actually fits within the legally allowed setbacks on the property anywhere in the city, was because I was having a discussion with somebody at one point about like setbacks are the dumbest zoning rule we have, or the height map that I made. So all of these pink buildings are buildings that are more than 40 feet tall, to kind of give people a sense of like, look, we don't live in this super short city, even though it feels like we do sometimes. And those are like basically every single one of those is a conversation, either in person or on a mailing list or somewhere else like that. Tax valuation. This one I love, like all of Cambridge's taxes per parcel, like high taxes per parcel always come from, all the really big, commercial and even residential properties over here. 'Cause new buildings just, they're more dense and they got more people paying taxes in them. So. All right, cool. I'm going to wrap it there. Thank you all so much for joining us. I really appreciate it. I just wanted to say, I'm going to make this so you can see me. There we go. Yeah, so I appreciate you all coming. I hope you enjoyed it. I will send a link with the slides and everything else like that, as well as any resources that I'll make sure they're all on the slide deck. I will also include a survey. Please tell me what I did that you would do better, or what you would love to see more about, or things you'd love to hear in the future from me, but also more importantly from A Better Cambridge. Like I said, I'm here with A Better Cambridge today. We organized this event. We're using the ABC Zoom, you know, and so this is really like, we try to do a lot of work around helping people understand the city we live in and moving forward to, you know, a better Cambridge. We would love to have you join as a member. You can either subscribe to our mailing list, which is the link here, or you can join us as a member and help support some of the activities we do. So that helps pay for things like the Zoom, pay for events, pay for, you know, getting authors out to the talks we've given and other things like that. So if you're not an ABC member, become an ABC member today. And if you are an ABC member, thank you for being here. And that's all I've got. So thanks everybody for coming, for asking great questions, and for making me feel amazing. It's great.